Hello class and welcome to your next lesson in National 5 Design and Manufacture. Today we're going to introduce a new topic which is commercial manufacture, which you will need knowledge of for your National 5 exam. So out in industry where products are manufactured for sale, there are two main types of manufacturing methods that you need to know about. There's one-off manufacturing, and this is for unique and bespoke products like the chair shown in the image, which are created by skilled workers and craftsmen. And then there's mass manufacture, where large volumes of identical products are produced on a production line, like in the one shown in the image with the bottles. Here, all the processes are automated and controlled by computers, and there's really not too many people involved at all. So mainly people with little manufacturing skills or people who are there to carry out quality assurance checks. So which method is right for a product really depends on the market. So this is one of our design factors that we looked at previously. And within the market context, what we have to consider is consumer demand. So if the consumer demand is there for a huge number of products, then we get something called the economy of scale. So there's money available for the manufacturer to invest in all these automated systems and production lines, because there's profits to be made from selling all the products that they will produce. With one-off manufacturing, this is typically where there's a much smaller consumer demand, more of a niche market, if you remember that term. And these people are willing to pay a higher price for a unique product. As designers and engineers, we must consider the impact that the mass manufacture of products has on society. And this is something that you could very well be asked to consider in your National 5 exam. So a huge benefit of mass manufacture is the economy of scale that's achieved. And this means that because you're producing so many units of a product, they're cheaper because all the resources needed are purchased in bulk. It also means there's a larger range of products that are made available to the consumer. And the advantage of this is that it gives people access to lifestyles that they may not have previously had. And what I mean by this, for example, is like people could decorate their house using the latest designs and the latest fashions from somewhere like IKEA, where well-designed products are affordable because of this mass manufacture. It also leads to improved quality assurance, meaning that there's a lot less faults in the product because they're created identically in a controlled process. There is potential for loss of manufacturing jobs associated with it, and this can hit areas particularly badly where they do rely on manufacturing as one of their main job sources. It can relate to things like economic decline in these areas. There's also potential to lose people with real skills, so skill sets in craft and manufacturing. But these people also have the potential to adapt and then move into different high-level roles within the manufacturing process. But we have to consider, if there's no jobs available, how can we keep these skills alive? How can we make people train, or do we need people to train in these jobs if the roles aren't available? And the final impact on society is that it does offer safer working environments, as the whole automated process means that people don't have to use heavy equipment and machinery as much as they might have had to in the past. So in industry, the automated mass manufacturing process is referred to as CAM, Computer Aided Manufacture. And this is where the whole production line is controlled by computers. You can see in the image, this is a bottled water production line, And this is a high-speed CAM system that includes everything: the moulding of the bottle, filling it, capping it, adding the label. And the person you can see in the image there is there to carry out quality assurance checks. We are now going to look at some of the benefits and the disadvantages of CAM, computer-aided manufacture. On the positive side, high volumes of identical products can be produced, and as we've talked about previously, because of this economy of scale that you achieve, the cost is lower per product due to this high volume. Computer-aided manufacture also means that the machining is quicker and you can run your production line 24 hours, 7 days a week if you want to maximise your production, and again this impacts on profits. Other benefits include high levels of product accuracy and detail. This can be achieved quite easily, and there's a minimal amount of waste material as the systems can be programmed to automatically optimise the production. Disadvantages of using CAM are that when the machines break down, you're at a loss, you're losing money, and until you get them back up and running, there's not much you can do. The impact of jobs that we talked about when we thought about society, and the high setup and maintenance costs. So to move to this type of manufacture, the business involved has to be really confident in their consumer demand and know that that level is going to be maintained, that level of demand for their product. Looking at now standard components, also called sometimes knockdown fittings. Some products can be mass manufactured as a whole, for example the bottled water that we looked at, but other products are mass manufactured as individual parts, and these individual parts are then assembled using standard components. And so by standard components I mean nuts, bolts, screws, and these themselves are then also again mass manufactured. So the best example I can think to give you of this is like IKEA flat pack furniture. So the benefits of using standard components is that they come in a range of sizes. So when you're designing a product, it's easy to include them, and you can look at what standard sizes are available and make your best choice. It also means that if they're lost at any point or damaged, then you can easily get a replacement. And this is really good in terms of environmental impact, because it means that products can be fixed rather than just binning them and buying a whole replacement. Standard components also save on manufacturing time and cost, because the machinery associated with them will be standardised as well to deal with the fittings. And finally, the components are quality assured, leading to less faulty products, and there's also no specialist skills required to use these standard components. Looking at the disadvantages, there is potential for poor assembly by the consumer, and there could be frustration when assembling it if any of the individual components are missing. Other examples of CAM include 3D printing, laser printing, and CNC routing. So firstly, looking at 3D printing, this is where a product is printed from a model, like a virtual model designed in computer drawing software. The model can then be printed, and this can be done in really, in the moment, just about any material. In the images shown, you can see a prosthetic leg that's been printed from titanium. There's a musical instrument, a violin, which is printed in a type of plastic. And then, really quite unusual, on the far side you can see a home that's been printed using concrete. In the images shown here, you can see some examples of laser printing or laser cutting. These products are produced again from computer-aided drawing software, and the design is sent to the printer, which then cuts or engraves the material. I've actually used this before to engrave on glass for a project, so you can use it in a whole variety of materials. In the photos we have an example of cutting metal and then plywood for an architectural model of a city plan. So using the laser printer, you can replace the need for having multiple different tools. So rather than having to change all the tooling bits throughout the process, the laser printer can be used as a single tool to create the design. The CNC machining. So the CNC stands for Computer Numerically Controlled Machines. And the best way to think about this is that any of the processes that we do in the workshop, for example, using the pillar drill, the bandsaw, the wood turning lathe, rather than these being carried out manually, it's where a computer is programmed to undertake these tasks automatically. And this can be done on an actual production line to make sure each of the products are identical. So for example, like on the four legs of a chair, if we turned them on the lathe, we would have to work quite hard to make sure they were all identical, but done in the production line, the CNC machines would make sure that each one completely matched. So again, benefits of using 3D printing and laser printing. The processes are fully automated, so again, cheaper workforce, no need for workshops because you just need the physical printers themselves. The products can be manufactured with software drawing skills only, so you don't need any craft skills. There's a very high level of accuracy and consistency because you're producing products from the same drawing model again and again. And because it's automated, there's less material wastage. Disadvantages are similar to what we've talked about, so a loss of employment in skilled workers, and there's a high capital cost associated with setting up, buying the printing equipment and then maintaining it and any training requirements associated with it. So we come now to using this knowledge in your exam and how you're going to do it. So we're just going to look at an example exam question from one of the past papers. So you can see here, question 9, 3D printers and laser cutters are widely used in the design and manufacture of products. And your question for 4 marks is, describe the benefits of using 3D printers and laser cutters to design and mass produce products. So note, because it says describe, we're writing in sentences, and I just want to go through some potential answers. So products can be manufactured with no craft skills because they are printed directly from CAD models, computer-aided design models. The process is fully automated, meaning a cheaper workforce, higher profits. Complex models can be created that are free from the restraints of traditional manufacturing techniques. Very accurate and detailed models can be created. It reduces the workforce wages, another way of saying, cost savings as the work is automated. Increased efficiency as machines can run 24 hours a day. There is consistency provided as each part is manufactured identically. And laser cutting can reduce lead times as there's less tooling required. And laser cutting has faster production rates than traditional tooling methods. You're not changing tools, that one laser can carry out a number of functions. And finally, with the laser cutters, or even with the 3D printers, they can automatically calculate the most efficient layout and reduce waste material. So any of those points could be used to answer that question, and you would have to describe 4 different points to get full marks. So class, that's the end of today's lesson, and I would now ask that you go and try the exam style questions that have been uploaded onto your Satchel 1. If you have any questions, please get in touch with your teacher, and when you complete your answers, share them on Satchel 1 with your teacher. So thank you.